Personal finance practice problem using Excel. Retirement saving calculation with the future value of an annuity formula. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information on the left-hand side, going to populate that into the blue area on the right-hand side. We're looking at a retirement savings type of scenario. Note that there's two general kind of scenarios that you'll set up in your mind when you're thinking about the retirement savings. So in other words, if you're thinking about saving over your earning years and thinking about how much you would need at retirement, you might phrase that one way to say, hey, look, I'm going to save as much as I can at this point in time on a yearly basis or periodic basis, and assume some rate of interest on that increased amount that I'm going to put into a savings account or some other retirement account, and then try to determine, given an average rate of growth, how much we would have at retirement, which we're going to say in 40 years at this point in time. You can compare that and contrast that to the other view you might look at, which would be how much money will I need at retirement in order to support my needs at the point of retirement after I'm done with my earning years, meaning you might then do an annuity calculation at that point in time to determine how much of basically a nest egg, what big chunk of money that you're going to need to be generating revenue if you were to then eat away at it as you consume that revenue over the retirement years. And then you would be thinking about a goal, an end goal to get to that lump sum of money that you would need at the retirement point. So in this case, we're going to start off with the first of the two scenarios, thinking about we're in our earnings years. We're going to try to save as much as we can and think about what if we were able to put away just say $5,000 for the next 40 years and get a return. We're going to estimate an average return or an even return in this case, which is one of the limitations of our present value. We're going to kind of estimate a nice even return of the 7% over that entire time period. Note, of course, you can get more complex with these kind of scenarios. You could then increase and say, I'm going to put 5,000 in for the next 10 years. And then the next 10 years, I think I'm going to earn more money and I'll put 10,000 in the future and so on and so forth. But to do that, you'd have to get a little bit more complex than simply just an annuity, right? You'd have to then make some adjustments because your payments into the retirement plan would not be even. But you can use these tools for a similar calculation as that as well. So let's look at this. We're going to say the investment each year is going to be $5,000 that we're going to put in. We're going to say it's going to be for 40 years. We got 40 years to save this stuff. And then the rate is going to be 7%. So we're going to say a rate of return 7%. So let's first do this with our running balance calculation, which you might think that's a tedious thing to do, given the fact we're talking about 40 years here, but not hard to do with Excel. You can go up, you can even do it on a monthly basis if you needed to, because you could just simply copy and paste this thing out. So let's do that. So we're going to start off at period 1. Note that when we think about an annuity calculation, we're typically not starting at time period 0. We're going to start, because the annuity happens, you assume, kind of at the end of the period, and that's how the calculation works. So if you have an initial investment at this point in time and then are adding to it, then you got to account for that basically initial investment and then the annuity component to it. So note, we're starting at 1 instead of 0. Then 2, we're going to select those 2 cells, and then I'm going to put my cursor on the autofill handle and drag all the way down. Notice it gives me that nice little number range that tells me where we are at, all the way down to 40 periods, and then let go. I'm going to center that by going to the Home tab, the alignment, and center it. So there we have it. And so then I'm going to put the investment in the outer column, and I'm going to have this as the initial payment. So the investment is the initial payment that we're going to have as we consider it to be our annuity, which we're going to say happens in year 1. So we're going to say this is equal to the 5,000, and then I'm going to have the investment just simply be the same 5,000. Now I'm going to do this fairly quickly because we've seen this calculation in the past. So I'm going to copy it down and I'm going to populate this assuming that it will be copied down from here, meaning any cells that need to be absolute referenced or make into an absolute reference, those typically outside the table from our data set, we will do so as we go. So we're going to say that there's going to be an increase, which will be equal to the 5,000, and then we're going to multiply that times the rate, which is going to be the 7%, and and that 7% is outside the table. So that's something that I do not want to move down when I copy the cell down. Therefore, I'm going to make it absolute. I'm going to do so by selecting F4 on the keyboard and or put a $ before the B and 5. Only a mixed reference is needed, but an absolute reference works and is easier to think about. The payment then is always going to be the same. So I'm going to say the payment equals that 5,000. This time I'm going to make that an absolute reference by selecting F4 on the keyboard, putting a $ before the B and the 3, and then enter. And then we've got the initial investment, which is going to be the 5,000, plus the increase, which might be interest. It might be an increase in value if it's in stocks and whatnot, or index funds, different types of investments that we have. But we're going to say the increase in value is going up by the 350. So I'm going to say plus the SUM shift 9 of these two. And then we're entering another or adding another 5,000 into it. We're saying each year. So then I'm going to close that up. And there we have it. So now we got the 5,000 plus another 5,000 that happened in year 2, plus the interest that is accumulating as we go. I'm going to select these 3 cells, and I'm just going to autofill it all the way down now. So I'm going to put my cursor on here. Now note, if you were not confident that this was going to work, you might autofill it down simply 1 cell. Double check these cells that they are doing what you expect them to, and then copy them the rest of the way down. Selecting these 3. Putting our cursor on the fill handle, dragging all the way down to 40 time periods down here, and there we have it. And so we're down here at, after 40 years, we're at the 998, 176. So almost at the million there in the 40 years at just the 5,000 per year. And we could see how the increase in the interest is happening here as we go. Fairly small amount of increase with the gain on the revenue that we're generating as we go through here. You could see how much we put in terms of total payments, the sum of this column. We would be putting in 5,000, that'd be 200,000 that we put in over 40 years, and how much we earned, which would be this column, which would be income from it. This would be the 798, 176 over this 40-year time period. So hopefully you can see the running balance table, really useful to get a better grasp of what would happen. Now, if you were to ask someone or even work with a financial analyst on this or something like that, they probably wouldn't graph it out like this, but would rather just do a future value of annuity calculation. So let's do that now and note the contrast between the two. You probably want to do both of these things in practice, right? Do the annuity calculation in Excel and then show it to yourself by actually calculating the payment to confirm what is in your mind and then get a better visualization of what is happening. So this is going to be equal to the future value, shift 9. We're going to pick up the rate, which is going to be the 7% over here, comma, and then with the number of periods is going to be 40 periods, and then comma. We do have a payment this time because we're talking about an annuity instead of a present value of 1. In other words, we're not just talking about 5,000 and the interest that will accrue on that or increase on it or be earned for it over 40 years, but having another 5,000 that will be inputting every year for the 40-year time period. So enter, and there we got our 998, 175. Let's make that a positive number by double-clicking on it. You could put a negative in front of the B here or in front of the F, which I choose to do in front of the F. So there we have it. So again, this would be the first thing that most people would probably do, or the simplest thing to do. But notice how much more information, how much better you get a grasp of it if you actually graph it out here and then put the table together for it, and you can determine how much your payments will be, how much the interest will be. You can look at the yearly interest as well. You can take into consideration tax impacts on different type of savings accounts, whether you put it into an IRA account or a 401k or outside of the IRA or a Roth IRA and all that kind of fun stuff that you can take a look at with the savings account on a yearly basis and consider the tax impacts related to it. Just to note also, you might be thinking, well, if that's 7%, that's going to be my rate of revenue or gain that I'm assuming. What about inflation? Because you might think, well, the purchasing power is going to go down over 40 years around 1 to 3% as well. So when you think about the actual purchasing power you're going to need, you're also thinking about where's that endpoint going to be. You're going to need more money, in other words, to retire 40 years from now, you would think, than today, if the economy does what hopefully goes well and that there's going to be some kind of inflation that will happen. So when you plan how much money you're going to need at the end, is that going to be enough money? In other words, in 40 years, right? It might be enough money at the starting point. If you look at it in 40 years, you're going to have different purchasing power related to it. So you got to take into consideration inflation. So let's do this a couple different ways. We'll do this with the formula now, which is less likely to be needed in when you go to a financial planner. They're not going to break out this future value formula most likely and putting it together that way. But when you're in a school setting, they might do that, and then we'll use the tables. So let's go ahead and put our cursor on. Let's go to column C and drag over to column J and hide those cells. Right click on those cells and hide them. And now we'll put this formula into a table over here and do that and try to build our table with it, which is good practice in Excel. So we have the future value equals of an annuity. That's going to be the P, which is the payment, the 5,000, times 1 plus the rate, which is 7%, to the N, which is the number of periods, or 40, minus 1 over R, 7%. So you can write that down and solve it algebraically. We're going to put it into our table to practice putting things into a table, into a tax return kind of format, into a financial statement kind of format. To do so, I want these two primary components to be in the outer column, and then I would like these other two primary numerator and denominator to be in inner columns, and then this more complex numerator I might break out to another inner column. All right, so we got the payment. That's going to be easy. That'll be in the outer column up top. The payment is going to be equal to 5,000. Then I'm going to pull into the inside, so this thing, and I'm going to try to get to the numerator first because it's going to be more complex. So let's pick up the numerator. I'm going to indicate a colon that this is going to be pulled inside. And then I'm going to say that this is going to be 1. And then the R, which is the rate, is going to be the 7%. So I'm right here. That's going to be equal to the 7%. Let's percentize that by going to the Home tab, Numbers group, percentize it, Font group, underline it. Then we'll have a subtotal, which will equal the SUM, Shift 9, up arrow, holding down Shift, up again, making that then a percent, Home tab, number, percentized, 107%. Then we're going to take that to the number of periods, or N. So that's going to be right here in our calculation. That's going to be 40 periods. And let's underline that by going to the Home tab, Font group, and underline. That's going to give us another, let's call it a subtotal, and that's going to be in the outer column here. Actually, I'm not going to bring that in the outer column. That's in the inner column. This is going to be equal to the 107%, Shift 6, caret, up 1, and enter. And so that's going to give us our 15. Let's add some decimals, make it more specific. Home tab, number, decimalize in it. So 14.19744 and so on. So that brings us to this whole piece, minus 1 here. So I'm just going to say less 1. And so that'll give us our whole numerator. So that'll give us the numerator finally. So that'll finish up this calculation. So let's indent this whole thing. Go into the Home tab, alignment, indent. And then I'm going to indent this again. Home tab, alignment, indent again. Let's underline this one. Home tab, Font group, underline. Bring this to the outer column. And this is going to be equal to that 14.97, so on, minus the 1. Gives us around 14. Let's add some decimals. Home tab, number, decimalized it. And then we're going to say this is going to be the denominator. So that's the whole numerator now that this whole thing is done. Denominator is simply going to be R, or the 7%. 7%, percentizing that. Home tab, numbers, percentize, Font group, underline. And then that's going to give us, let's call this a subtotal. And that's going to be in the outer column now. That's this whole thing. We've now got this whole thing that's going to be in the outer column, which will then multiply times P. Notice we're only doing calculations in one column at a time. In other words, I'm not jumping from a calculation from one column to the other. That's common practice in like financial statement type settings. So this is going to be that divided by the 7%, the num divided by the denom. Adding decimals, Home tab, numbers, decimalizing it, and then underline, font group, and underline, and that'll finally give us the future value. Finally give us the future value, which will be this times this, or the outer column now, only doing things in one column at a time, the 5,000 times that 199.63 whatever, and so on. Let's add a couple decimals here by going to the Home tab, number, couple decimals, so 998.175.56. Let's do it one more time, this time with the tables. So hopefully a school doesn't make you do that algebra too much on it. And they might give you the tables, which is slightly nicer, which you're just going to take this 5,000 and multiply it times the amount from the table, which would be at periods 40, rate 7. So we're looking 7 on the rate, 40 all the way down at the bottom of the table, way down here, 199.635, 199.635, 199.635, 199.635. Adding some decimals, Home tab, number group, decimals. This is from the table. Let's go ahead and underline that by going to the Home tab, font group, and underline, and that'll give us once again the future value of an annuity. Multiplying this out, this is the 5,000 times the 199.635. Add a couple decimals there, Home tab, number group, couple decimals. We're at the 998.175, slightly different than the 998.175.56 due to the fact that this number right here, which is the number that kind of is used to build the table, is really more than 3 to 4 digits out. So they rounded it on the table, resulting in a slightly different number, which can be somewhat more distinct when you're talking about larger numbers, as you often are when you're looking at retirement type of accounts. So just notice that that rounding difference could be larger as you deal with larger numbers depending on the circumstances. Okay, let's unhide and recap. So I'm gonna put my cursor on L, drag on all the way back to B, and unhide those cells. Right click and unhide. So there we have it. I should probably run a spell check. Did I misspell anything? Numerator spelled wrong. Okay, got it. And then, so now we've got this 5,000 all the way down, gives us that 998.176. So notice this table, very useful. Then we got the future value. This is probably what someone would give you if you talk to like a financial advisor. And then it's really useful to plug that into a table so you can visualize it. You can get to that same 998.175.56 with the formula, and you can get to a close number with the use of the tables, which you might see in book problems, mainly in a school setting.